Hello everyone, in this video we are going to discuss Pure Mathematics 3, May June 2020, paper 3-2. Question number 1. Find the quotient and the remainder when 6x to the power of 4 plus x cubed minus x squared plus 5x minus 6 is divided by 2x squared minus x plus 1. So in order to find the quotient and the remainder, for this case we can do the long division. Six x to the power of 4 plus x cubed minus x squared plus 5x minus 6 divided by 2x squared minus x plus 1. So in order to eliminate 6x to the power of 4, first we multiply 2x squared by 3x squared. So it will become 6x to the power of 4 minus 3x cubed plus 3x squared. And then we subtract. Can cancel that one. We do the same process now. We have to eliminate 4x cubed, so we multiply 2x squared by 2x, so plus 2x. We do the same process, subtract again. Here we can cancel 4x cubed. The remaining is negative 2x squared plus 3x minus 6. Yeah, we do it one more time. We multiply this one by negative 1, so this one minus 1, so it's minus 2x squared plus x minus 1. And we subtract again. So the quotient will be 3x squared plus 2x minus 1. This one is the quotient, and the remainder is this 2x minus 5. Question 2. The variables x and y satisfy the equation y squared is equal to a e to the power of kx, where a and k are constants. The graph of ln y against x is a straight line passing through the points 1.5, 1.2 and 5.24, 2.7 as shown in the diagram. Find the values of a and k correct to 2 decimal places. So we have equation y squared is equal to a e to the power of kx. We apply ln on both sides. We'll have 2 ln y is equal to ln a plus kx, and then we move 2 to the right hand side of the equation and rearrange a little bit. Ln y is equal to k over 2x plus ln a divided by 2. So here it's the same comparing with the straight line equation. Y equals mx plus c, in which y is equal to ln y. So the gradient of the straight line is k over 2. So we can find the gradient from the graph given. So the gradient of the straight line is 2.7 minus 5.24 over 2.7 minus 1.2 divided by 5.24 minus 1.5. The gradient is 0.401. So the value of k over 2 is equal to 0.401 because the gradient is k over 2, and k is equal to 0.80, correct to 2 decimal places. So now the equation, substituting the value of k, become ln y is equal to 0.40 x plus ln a divided by 2. In order to find the value of k, we can substitute the value of x and y using the first point or the second point. So let's say we use the first point. The equation become 1.2 is equal to 0.40 x plus ln a divided by 2. Sorry, the value of x is 1.5. It's 1.5 here. Yeah. Solving this equation, we can find the value of a is 3.31. Now let's continue to number 3. Question number 3. Find the exact value of integral x to the power of 3 over 2 ln x dx from 1 to 4. For this question, we are going to use integration by part. The formula for integration by part is integral u v prime dx is equal to u v minus integral u prime v dx. For this case, u is equal to ln x, so that u prime is equal to 1 over x, and then v prime is equal to x to the power of 3 over 2. V is integral x to the power of 3 over 2 dx. So it's equal to 2 over 5 x to the power of 5 over 2. So we continue the integration using this information. uv is 2 over 5 x to the power of 5 over 2 ln x minus integral u prime times v 1 over x times 2 over 5 x to the power of 5 over 2 dx. We can simplify this one into two over 5 x to the power of 3 over 2, and then we can easily integrate that form. The integration will be 5 over 2 x to the power of 5 over 2 ln x minus 4 over 5 x to the power of 5 over 2. And then after this one, we substitute the lower and the upper boundary of the integration, which is 1 and 4. 1 and 4. The final answer will be 128 over 5 ln 2 minus 124 over 25. This is the exact value. Number 4. A curve has equation y equals cos x sine 2x. Find the x coordinate of the stationary point in the interval 0 less than x less than pi over 2, giving your answer correct to 3 significant figures. So to find the stationary point, we need to find the first derivative of the equation. and then equate the first derivative with 0. To differentiate this one, we are going to use product rule. So y prime is equal to u prime v plus u v prime. That's the formula for the product rule. U is equal to cos x, this one, and v is equal to sine 2x. So we continue the differentiation. U prime v is negative sine x times sine 2x plus uv prime. Uv prime is cos x times 2 cos x. So it's better we put the 2 in front here. So cos 2x. And then equate the result with 0. Using double angle formula, we can simplify this equation into negative sine x times 2 sine x cos x plus 2 cos x times cos square x minus sine square x is equal to 0. Then we can simplify into negative 2 sine x sine square x cos x plus 2 cos cube x minus 2 cos x sine square x is equal to 0. And then we can add the same term. So to make it simple, this one become 4 sine square x cos x plus 2 cos cube x is equal to 0. And then factorize, pulling out the 2 cos x from the bracket. Inside the bracket we still have negative 2 sine square x plus cos square x. Our solution comes from this one. So negative 2 sine square x plus cos square x is equal to 0. It is easy to show that 1 is equal to 2 tan square x by dividing both sides with cos square x. So tan x is equal to square root of 1/2. actually plus or minus square root of 1/2, but because the interval values of x is from 0 until pi over 2, we take the positive value only. And finally, the value of x will be tan inverse of square root of half. The answer is 0.615 radian. Question number 5. 5a. Express square root of 2 cos x minus square root of 5 sin x in the form r cos x plus alpha, where r greater than 0 and 0 degrees less than alpha less than 90 degrees. Give the exact value of r in the weight and the value of alpha correct to 3 decimal places. So r can be found by using the formula square root of a square plus b square. So it's equal to square root of 2 plus 5. So the exact value of r is square root of 7. While for alpha can be found by using the formula alpha is equal to tan inverse of b over a, square root of 5 over square root of 2. The value of alpha is equal to 57.688 degrees. (5b) Hence solve the equation square root of 2 cos 2 theta minus square root of 5 sin 2 theta is equal to 1 for 0 degrees less than theta less than 180 degrees. From our previous result, we can write this equation into square root of 7 cos 2 theta plus the value of alpha. The value of alpha is 57.688 degrees, and that is equal to 1. So 2 theta plus 57.688 degrees is equal to cos inverse 1 over square root of 7. The values of theta in the given range will be theta is equal to 5.1 degrees or theta is equal to 117.3 degrees. Number 6. The diagram shows the curve y equals x over 1 plus 3x to the power of 4 for x greater than or equal to 0 and its maximum point M. A. Find the x coordinate of M, giving your answer correct to 3 decimal places. So M is the maximum point. First, we need to find the first derivative of y. This time we are going to use the quotient rule. The formula for the quotient rule is y prime is equal to u prime v minus u v prime divided by v square. And then later we are going to equate this one with 0. U is x and v is 1 plus 3x to the power of 4. So y prime will be 1 times 1 plus 3x to the power of 4 minus x times 12 x to the power of 3 over 1 plus 3x to the power of 4, and then equate with 0. Since the right hand side of the equation is 0, we need to focus only at the numerator. So 1 plus 3x to the power of 4 minus 12x to the power of 4 is equal to 0. 1 is equal to 9x to the power of 4. So x is the fourth root of 1 over 9. The value of x correct to 3 decimal places is 0.577. B. Using the substitution u is equal to square root of 3x squared, find by integration the exact area of the shaded region bounded by the curve, the x-axis, and the line x is equal to 1. So the area using the integration is a is equal to integral from 0 until 1 of x over 1 plus 3x to the power of 4 dx. The substitution that we are going to use here, it's been given from the question, is u is equal to square root of 3x squared. So du over dx is equal to 2 square root of 2 square root of 3x, or dx is du over 2 square root of 3x. So we can continue the integration here. So it's integral x over 1 plus, since u is equal to square root of 3x squared, then 3x to the power of 4 is the same as u squared. And then dx can be changed into du over 2 square root of 3x, which can be simplified. We can cancel this one. We can simplify into 1 over 2 square root of 3 integral 1 over 1 plus u squared du. The integration of this is tan inverse of u. So So 1 over 2 square root of 3 times tan inverse of u. But since we are using substitution u equals square root of 3x squared, it means that the lower and the upper boundary should be adjusted also. So when x is equal to 0, u is equal to 0, and then when x is equal to 1, u is equal to square root of 3. So we put the lower and the upper boundary here, then the one that has been adjusted. So from 0 to square root of 3. This one from 0 up to square root of 3. Substituting the lower and upper boundary, the final answer will be square root of 3 over 18i in exact form. Question 8a. Solve the equation 1 plus 2iw plus iw conjugate is equal to 3 plus 5i. Give your answer in the form x plus iy, where x and y are real. So first we substitute w with x plus iy and w conjugate with x minus iy. The equation become x plus 2i times x plus iy plus I times x plus iy is equal to 3 plus 5i. And then we expand, removing all the bracket. This is from the first one, and then this one is from the multiplication of I plus x minus iy. Don't forget, I square is equal to -1. Comparing the real part of the left hand side of the equation and the real part of the right hand side of the equation, we have the first equation, x minus y is equal to 3, and then for the real part, for the imaginary part, the second equation is 3x plus y is equal to 5i. Solving these two equations simultaneously, we will find that the value of x is equal to 2 and the value of y is equal to -1. So w is equal to 2 minus I. 8b. I. On a sketch of an Argand diagram, shade the region whose points represent complex numbers z satisfying the inequalities. The magnitude of z minus 2 minus 2i is less than or equal to 1, and the argument of z minus 4i is greater than or equal to -1/4 pi. this one we can write into z minus 2 plus 2i less than or equal to 1. This is a circle with center 2,2 and the radius is 1, and we said the region is inside the circle. So here we have the circle with radius 1 and center 2,2. Now we are going to draw the argument z minus 4i greater than or equal to negative 1 over 4i. We start the line from point 0, 4 and then draw the argument negative pi over 4. The line will exactly passes through the center of the circle. The shaded region will be here. For the second part of this question, we have to find the least value of imaginary z for points in this region. It is obvious that the point with the smallest value of y is this point. And then since this one is 45 degrees, it is easy to understand that the angle here is 45 degrees. And then we know that the length of this line segment is 1. And then with the help of trigonometry, the length of this line segment will be half or square root of 2 over 2. So this one is the least value of y, or the least value of imaginary z. So the minimum value of y will be 2 minus square root of 2 over 2. Question number 9. The diagram shows the curves y equals cos x and y equals k over 1 plus x, where k is a constant for 0 less than or equal to x less than or equal to half pi. The curves touch the point where x equals p. A. Show that p satisfies the equation tan p is equal to 1 over 1 plus p. Because the question says that the curves touch each other, we can say that when x equals p, both curves share common points and also common tangent. So we can write for the first equation that cos P is equal to K over 1 plus P. So the first equation, cos P is equal to K over 1 plus P. This is the first equation. And then they also have the same tangent. The gradient of the tangent for the first curve y is equal to cos x. The gradient is y prime is equal to negative sine x. While for the second curve, y is equal to k 1 plus x to the power of negative 1. The gradient is negative k over 1 plus x to the power of 2. So the second equation will be negative sine P is equal to negative k over 1 plus P squared. This is the second equation. Or we can cancel both negative in the second equation. Dividing the second equation by the first equation. So the second equation divided by the first equation, we will get tan P is equal to 1 over 1 plus P. So we have shown that tan P is equal to 1 over 1 plus P. So this is the last question for this paper, number 10. With respect to the origin O, the points A and B have position vector given by OA is equal to 6i plus 2j and OB is equal to 2i plus 2j plus 3k. The midpoint of OA is M. The line N lying on AB between A and B is such that AN is equal to 2NB. A. Find a vector equation for the line through M and N. In order to find the vector equation of a line through M and N, we need to find the position vector of M and of N. First, the question says that the midpoint of OA is M. It means that OM is equal to half ON. Is equal to half OA. Since OA is 6i plus 2j, then OM will be half of it. It is 3, 1, 0. For position vector of N, we can start from this one. AN is equal to 2NB. So we write AN is equal to 2NB. or ON minus OA is equal to 2 times OB minus ON. And then using algebra, we can have 3ON is equal to 2OB plus OA. So it's equal to 3ON is equal to 2 times OB. OB is 2, is 1, 2, 3 plus OA is 6 to 0. Solving this equation, we'll be able to find that the position vector of ON is (10 over 3 to 2). And then since we already have position vector of OM and position vector of ON, we can find the direction of the line, which is the vector of MN itself. So this is the direction MN. MN is ON minus OM. 310. The direction of the line will be (1 over 3, 1, 2). So the equation of the line passes through M and N is R equals 1 point passed by the line. We can use point M or N. This 1 point on the line 310 plus the parameter lambda times the direction 1/3, 1 and 2. The line through M and N intersects the line through O and B at the point P and at the point P. B, find the position vector of P. So we have found the line equation passes through M and N from our previous answer. The line passes through M and N from our previous answer is R is equal to (310) plus lambda times 1 over 3, 1, 2. This is the line equation passes through M and N. And then the line equation OB, because it passes through the origin, this one 0, 0, 0, this is the origin, plus the parameter we use mu, times the direction, which is vector OB. Vector OB from the question is 2, 2, 3. And then we can make two equations using the value of x and y, or x and z, or y and z. For this one, it seems that it is easier to use y and z. The first equation is 1 plus lambda. This one is equal to 2 mu. And then for the second one, using the value of z, 2 lambda is equal to 3 mu. Solving these two equations simultaneously, we will be able to find the value of lambda is equal to 3, and the value of mu is equal to 2. And finally, the position vector of P, which is OP, is 4, 4, 6. C. Calculate angle OPM giving your answer in degree. To find angle OPM, we need vector OP, which is 4, 4, 6, and also vector MP. Vector MP can be found using formula OP minus OM, and it's equal to 136. And then using the scalar product, OP dot MP, OP dot MP is equal to the magnitude of OP times the magnitude of MP cos alpha. Alpha is the angle between MP dan OP. So 4, 4, 6 dot 136 is equal to square root of 68 times the square root of 46 cos alpha. Solving this equation, we can find that alpha is equal to 21.6 degrees. Okay, I think that's all. I hope this video can help you in preparing for your exam. Good luck everyone.